Today we're going to be talking about the scientific method. So by the end of the lesson, you should be able to explain the importance of the scientific method, write a testable hypothesis, and analyze your data and compare it to your hypothesis. So what is science? Science is what we use to understand natural phenomena, things that are going on naturally in the world around us or inside your bodies. There are two different types of science that we're going to talk about. We've got discovery science and hypothesis-based science. Discovery science is something that describes nature. It uses inductive reasoning, and what that is you're using data to make a generalized conclusion. So the first one we're going to talk about is discovery science. Discovery science is what describes nature. It uses inductive reasoning to do this. And what inductive reasoning is it's using data to make a generalized conclusion. So my example says that the first red jelly bean I ate tasted like cherry. Well, then the next red jelly bean I ate also tasted like cherry. So that means all red jelly beans that I eat are going to taste like cherry. So what we're saying that is if something happens the same way multiple times in a row, you can make that generalized thought that every time you do that thing, you're going to get the same end result. So let's say you're boiling water. Well, the first time you boiled water, you had it on too high and it boiled over. Well, the next time you boiled water, the same thing happened. So now you can make the general conclusion that every time you boil water and you turn the heat on too high, it's going to boil over. Now let's talk about hypothesis-based science. This uses deductive reasoning, and deductive reasoning is when you're using things that you previously know in order to form a conclusion. In order for that conclusion to be correct, though, you need to know that your previous knowledge is also correct. So examples are like dogs are mammals. We know that dogs are mammals from different scientific studies, the fact that they give birth to live babies, and many other reasons. And another thing we know is that all mammals have some type of hair or fur. So with the fact that we know dogs are mammals, and we know that mammals have some type of hair or fur, well then we can make the conclusion that all dogs have hair or fur. So hypothesis-based science is taking information that you know on the topic and using that to make a conclusion. Now let's talk about the scientific method. So below I have all of the scientific method steps that we use. We've got observation, hypothesis, experiment, data collection, conclusion, and retest. Let's talk about observations. Observations are gathered through your senses. It's something that you notice, either with your eyes, ears, smell, any kind of sense that you have. So a scientist noticed something in their natural world and they ponder on that something that they've noticed, and they can either decide to take it further and make an experiment out of it, or it can just be some observation that they put in their back of their mind. An example of an observation could be noticing that many salamanders near a pond have curved tails instead of straight tails. So you saw this, and it was something out of the ordinary or something that you're not used to seeing. And now we're going to talk about hypothesis. A hypothesis is a suggested solution to a problem or a suggested answer to a question that came up. So with the salamanders that we saw with curved tails instead of straight tails, we could say the salamanders have curved tails due to a pollutant in the moist soil that they live in. That would be a hypothesis that we could write for that situation. A good hypothesis needs to be testable, though. So scientific knowledge is always ever expanding, and new methodologies can be applied to old questions. So something that they could have come up with back in the 1850s, we could use that thought, that observation, that hypothesis they made back in the 1850s, as long as it's testable, as long as it's something we can use, we can take it through all of the technology and different things that we have today and retest it. Some examples of a testable hypothesis could be cacti have spines to reduce herbivory. So to reduce the fact that herbivores are eating them. UV radiation causes limb deformities in amphibians. We could do different types of tests to figure out if these things are true. With the cactus, we could remove all the spines from the cactus and see if that increases herbivory or not. With UV radiation, we could subject different amphibians to different amounts of radiation, of UV radiation, and see if that affects their limb deformities or not. Some examples of untestable hypotheses, these are something that are more subjective and aren't really testable in a quantitative state. So one would be women are more moral than men. You could think women are more moral than men, but that's not really testable because it's more subjective. Another example is dogs are smarter than cats. Well, that's another subjective thought because a dog person would say that dogs are smarter than cats, but a cat person may say that cats are smarter than dogs. So hypotheses need to be testable in a quantitative or in some way that is not subjective to the person that's doing the testing.